This is the moment when Earth and Mars meet again after 780 days. If you launch a spaceship from Earth right now, you could land on Mars in just 40 days of flight. But Mars is not stationary. By the time your ship arrives, Mars will have already moved 21 degrees, a distance of 84.2 million kilometers. So you, being clever, think, what if you let Mars return to its closest point to Earth, then subtract those 21 degrees, and launch your ship from Earth at that moment? Then, 40 days later, the ship would meet Mars right on time. But there's another problem. If you fly the ship in a straight line toward Mars, you would have to keep the engines firing to fight the sun's gravity. But the ship simply does not carry enough fuel. So instead, you give it a quick burst of speed at launch, an instantaneous acceleration, then shut off the engines and let it coast. With no other forces acting on it, the ship's kinetic energy gradually turns into gravitational potential energy. It slows down until at its farthest point, all kinetic energy is spent. Then, under the sun's gravity, it starts falling back toward Earth, returning to its starting point, tracing out an elliptical orbit. Now you can draw a conclusion. By carefully controlling the instantaneous acceleration at launch, you can shape the ship's orbit so that it is tangent to Mars's orbit. When the spacecraft reaches that tangent point, you fire the engines a second time, not to let it fall back to Earth, but to use that boost to slip directly into Mars's orbit. In other words, as long as you calculate the flight time and the relative position of Mars, you can precisely execute a landing on Mars. Assume both Earth and Mars follow perfect circular orbits. Earth's orbital radius is 150 million kilometers, and its orbital period is 365 days. Mars' orbital radius is 230 million kilometers, with a period of 687 days. Add the two radii and divide by 2. The semi-major axis of the transfer orbit from Earth to Mars is 190 million kilometers. So how long will the spacecraft take to reach Mars? That will not stump you either. You recall Kepler's third law. It states that the square of a planet's orbital period is proportional to the cube of its orbit's semi-major axis. In other words, 150 million kilometers cubed divided by 365 days squared equals 230 million kilometers cubed divided by 687 days squared, and also equals 190 million kilometers cubed divided by the square of the transfer orbit's period. From this, a simple calculation gives that the orbital period of the transfer orbit is about 520 days. Flying only halfway to Mars's orbit gives 260 days. Of course, when the ship arrives, Mars must be there too. Otherwise, you have flown for nothing. So you must also calculate how far Mars travels in those 260 days. 260 days divided by 687 days, multiplied by 360 degrees, equals approximately 136 degrees. The angle between Earth and Mars at that time is 44 degrees, and so you reach the conclusion. Whenever the angle between Earth and Mars is 44 degrees, you launch the spacecraft. And after 260 days of flight, you can land on Mars. This launch window appears only about once every 780 days. That is why every 2 years, space agencies around the world all send their Mars probes at the same time. So congratulations, you have just invented the Hohmann transfer orbit. But it does not end here. After 260 days of hardship, the probe slows down by firing its engines to be captured by Mars's gravity. By repeatedly firing its engines and flying around Mars, it gradually closes in, until at the right distance and position, it plunges into Mars's atmosphere. Because Mars's atmosphere is quite thin, parachutes alone are not enough for a safe landing. Retrockets must fire to slow the descent. And when the probe enters the atmosphere at high speed, the air ahead is violently compressed and heated, becoming ionized plasma that blocks radio communication. Everything must be handled by the probe itself. That is the blackout zone. Even today, these challenges still hinder humanity's exploration of the cosmos, but I believe that none of them can stump someone as clever as you.